This is taking a lot longer than I wanted it to, purely because I have to stop. It's bollocks. This build is going to take longer than I normally spend because, number one, I spend a lot of what am I talking about? Please bear in mind that I can't just start something and then finish it, because I can stand here for 15 minutes, be in agony, and have to lie down for 15 minutes. Or I could stand here for 2 hours and then have to lie down for an hour. That's the way it works. I don't know how long it's going to take, purely because I don't know how long I can stand up. I don't know how long I'm going to lie down afterwards. I have to be careful, because if I overdo it, I can't walk the day after. I've been trying to work things out of how and what is going where, and it ain't easy. Now I've got the battery in the middle, the BMS is going there, that's an absolute. The phase runner isn't, I'm not using the phase runner because I didn't want to anyway, but it fits perfectly here. It's completely flush. The plate will go over the top, hold it in place, everything, but I'm not using the phase runner, and I'm not telling you what I'm getting because I don't want to. The DC-DC controller there, which is 70 to 108 volts, 108 volts down to 12 volts, which I need that for all the lights and everything else that I need. That goes there. This has got to go there because these are the mounting points, the mounting bolts for the stem. I know the place is like a bomb site, but you know, I'm working. This is a wheel. It's a bit big. It's rather big. Anyway, this is how it's going. What I've got to do is, in the centre here, I've got a piece of. Where is it? I've got that piece to put across there. That bar's going to go in between, so as when I pull it in, it's not going to pull against anything. And then I've got another piece that I'm going to drill. I'm going to cut another piece that big, and then I'm going to slot it in there, so as it'll act as a pivot point. So as when I pull tight, I can pull down on this, and it won't affect this at all. So that's that's done. Bollocks, shit and. The brake is put in position and it does fit there. Not very well at the minute because I've still got a lot of adjustment to do. It's still freewheeling, but the brake does actually fit. The only thing I'm a bit concerned about is this, which is the torque. The only thing I've got is torque washers, and I don't like torque washers, but I really don't know what to do with it yet. And then, to be honest, they should be alright, but I don't know yet. I think I'm going to have to put one of these on the inside just to make it, but anyway. So that's that done. It is all motor, you know. It's all motor. Look, it's just the motor. The tyre width is the motor width. Anyway, I reckon I'll be able to pump around about 11 kilowatts through that. It is a 3 kilowatt continuous wheel, so you should be able to quadruple it just for very short bursts. It has got a ferrofluid in it, everything's sealed, the tyre's still up, so I know I haven't punctured the inner tube, so it's going to work perfectly. Oh yes, while I think about it, here, this is the cross brace that keeps the swinging arms in place. It stops them from twisting. Obviously, because I've had to put these on the outside now, this thing's going to be not big enough. So I have ordered a solid piece of aluminium, square section, it's square, to go here so as I can clamp these things in place and stop them from actually twisting. That's the only way. The only other way is to have this CNC made, and I can't do that. because it's going to cost too much. All these with the red dot were all at 3.7 volts. All the ones without were at 3.5, and I've had to balance them all. I should have checked them before I used them, to be honest, but it's taken quite a while to get all them down to 3.5 volts, down to the lowest voltage. So that's done. And now I'm going to get my favourite spot welder out and use it. This is my Lipo battery. This can deliver upwards of 1000 amps pulse, and it does. I built it specially out of Tattoo, what are they, 16 ampere hours 6S Lipos. I cut them apart and stuck them all together into a 3S configuration. It took a long time to get it done, but it works. Anyway, I need to try and talk to you about the voltage and the current. If you have too low a voltage, what happens is it just melts the metal. It just burns everything around whatever you touch. It just makes it hot. It doesn't fuse it. You need a higher voltage to actually create that fusion part, and also you need the high current in order to create the fusion part. So you need high voltage, high current. When I say high voltage, 12 volts is perfect. Anything higher just completely blows everything apart. What happens is, if you've got a LiPo that can't handle the current, or you've got a lead acid battery that can't handle the current, what happens is as soon as you try to spot weld, the voltage drops off massively, and the current drops off massively accordingly. So if you've got something that will deliver virtually flat line with voltage and current, it gives a perfect weld. Now that's why I built this, is because this will deliver 1000 amps. Car batteries, yes, they will deliver 1000 amps, but you probably have to put 2 or 3 in series in parallel. The same with Lipos. If I was to do just that one there, it might not have enough current. This is 3S 4P pack. The other thing that you've got to bear in mind is the tips themselves. Do not sharpen them. What you want to do is you want to get as big a weld as you possibly can. Obviously it's limited by your battery. It's always limited by your battery. This is the thing that welds, not that. All that does is controls the pulse width. This is what welds. So people are saying, what's the best spot welder? It's irrelevant to the best spot welder. If you haven't got the battery to actually do it, it doesn't matter what you use. I could use a £15 spot welder on eBay, and I have done, or AliExpress, and it creates perfect welds, no problem at all. This has just got all the added extras whereby you can plug other things in, and a foot pedal, and you know. So take this out of the equation. The thickness of these wires does matter because it carries the current. Everything's revolving around the battery and the output, and the loss of voltage and the loss of current. So the less loss you can have, the better the weld you're going to get. Now the other thing I need to talk about is the weld itself. Here's a 4S. Is it 4S? A 4S pack that I did. Now if you have a look at the size of the spot welds in this is when I first started spot welding. This was just a low current pack, so the spot weld sizes don't really matter. These were actually made with brand new tips, and they were quite sharp and quite small tips as well. Now even these, to me, they're a bit too small. You need bigger tips. But I can't get them in this sort of configuration and whatever. The bigger the surface area of the tip, the more current you're going to be able to carry through the nickel. The thickness of the nickel is completely irrelevant if you haven't got the contact area on the weld itself. If you look at that, the contact area, that is what, 1 millimeter? I think round about 1 millimeter. So you've got 1, 2, 3, 4, 5. You've got 6 square millimeters of contact area. Now, if you work that out on wire gauge, that ain't a lot. That won't handle a lot of current. The main area of heat generation is on the positive and the negative points. With the combination of chemistry and spot welding, the contact area is the hottest point, so you're positive and negative. This bit here doesn't necessarily get too hot unless you've got a problem with the battery and it fuses out and blah blah blah, but the main area of concern is actually on the contacts. The more welds you can get on there, the better. The thicker the weld, the less welds you have to do. If I was to make these sharp, the contact area is so small and it'll blow a bloody hole. Well, it might blow a hole in it, but when you've got thicker ones, you can ramp the pulse width up, and it actually fuses a hell of a lot better. So the wider you can get away with, the better. The bigger the battery, the better. If it doesn't sag, you're perfectly fine. This doesn't sag. It's virtually none. A lot of people have said to me, I bought this spot welder and it's shit because I can't use it, and it turns out they're using a knackered old car battery. Now the other common thing as well is they say, oh, it doesn't weld on the negative side all the time. That's purely because of the battery. If you had a battery that was capable of handling the current that you need to spot weld, you would have a perfectly good weld on the positive and the negative terminals when you do your spot weld. So for all the people who have asked all these questions, and I've gone into it 1,000 times, refer back to this video because it makes no sense whatsoever. With that in mind, I'm going to plug this in. That goes in there. So I'm running a 7 millisecond pulse on this. That's all I need, and that's with 0.3mm nickel. I have to put that there. I've got to put that there, and I've got to get one battery. There's my foot pedal lead, which I'll put well out of the way. I've extended the foot pedal lead. This is just very thin wire. That's all you need because it's purely a contact and nothing but. Obviously I've still got to cut the nickel, which is...
I didn't hear that. Please try that again.
What? Here's my nickel, which is 0.3mm. I think it's 0.3mm anyway. Yes, it is 0.3mm because that's what I bought. Now this is pure nickel. It's not your bloody tin coated nickel. This is pure nickel. The way you can tell is when you spot welding, it doesn't spark. If you've got sparks coming off everything, it's tin coated nickel. If I had a shit battery on there, you couldn't weld this. You couldn't weld it. What I've got to do is cut these to size. I think what I'm going to do, I'm going to start with the series ones and then I'm going to do the parallel ones. Now, when you're designing batteries and stuff, you've got to make many considerations. These batteries are going to go like that. But I want to keep as close as I possibly can so as I can put padding around absolutely everything to isolate it from the casing. So what I'm going to do is, and I've still got a bit of calculating to do, but I'm going to put those like that. I'm going to do the series ones first, which I can do, and then I'm going to run parallel all the way on there and also on the back, but there's going to be a bit of a difference on the back. That's so as I can do this. I can then put them like that and they'll go a lot closer together. All will become apparent when I've finished it. Right, I'm ready to spot weld. If you want to be really anal about it, you can use, where are they? One of these neo diddly mig whatever magnets, I ain't got a clue. And hold the nickel bits on. Obviously the piece that you're not spot welding. So I'm going to do positive to negative, and then I can do positive to negative, go all along there, then turn it over and then do the other side. After I've gone all these, I've done 6 welds on each. After I've gone all these, I'll go around and I bend all the positive ones down just to stop them from sticking up and possibly catching on something. So that's all done. So now I can go on to the other side. Now if you look, I've done that side there, so what I've got to do is the other side, positive to negative there. If I was to do that one and that one, you'd end up in a fire, or that one and that one, you'd end up in a fire. You've got to do the opposing ones that aren't already joined. That one you've got negative that goes to positive, to negative, to positive, to negative, to positive, to negative, positive, like that. So it's definitely those two that you need to do. I've cocked it up before, believe it or not. So I welded that side and then I welded that side. Believe me, it ends up in fire. So you've got to be very, very careful. So at the end of this, the negative of the battery is going to be there and the positive of the battery is going to be there. I hope. Is it? Yes. Oh, by the way, I'm putting it on this board because it's level. My computer desk, it bows a bit in the middle and I don't like it. So I have to use something. Call it OCD, I don't care. In the corners here you can see that I've folded down all the sharp edges and I've gone over all these edges here which sometimes lift up when you're welding, and it's just a preventative thing. I don't like sharp edges anywhere near anything. You know, the more careful you are, the more time you spend on it, the longer it's going to last and the safer it's going to be. So I've done that one. I've got to do the other one and then I can join them all together. Like I say, I'm not doing the parallel links until I've done the series links. I am now going to measure the voltage on these just to make sure that they're near enough the same. If they're not, then I've got to go through it and find out which cell is actually down, where it's, you know, so I can charge or discharge it. But after that I can then do the other one and then parallel them up. Oh, that was close. Ho, ho, ho. Don't get complacent. That would have been very bad. I nearly did it. Just to explain what would have happened if I'd have put that across there. Because it's already bridged on the other side, as you can see. Even if I'd have got this loose like this and put it on there, it would have immediately fused. Immediately. You can't get it off because it's burning. The only way you can get it off is with pliers, and you're too bloody late then. If you're lucky, it immediately just fuses out, but if it starts smouldering, the batteries, they'll go into thermal thermal runaway, and then they start burning, and then you've got a fire. It's going to be a big fire as well with two cells like that. So you've always got to be careful. Do not get complacent. I do it. I get complacent and I'll think, ooh. The other reason why I'll go over these and bend all the tabs down, the one I've just done, so I always bend these tabs down purely because you've got more contact area with the button. I flatten these off just in case. It just takes all the burrs off, so you don't, if it comes into contact with anything, it's not going to hurt it. I can run my hand cleanly over that. Anyway, that's done. So the next job I've got to do, which is going to be tomorrow, is join them all up. I'm going to check the voltage across there, make sure that they're all 60 something volts, and then that's done. And then I've got the worrying part of joining them together. That is worrying. I don't like doing the parallel. Don't mind the series. When you come to do the parallel, anything can go wrong. I'm not talking to myself. Yeah, I'm not. I'm talking to this. I'm going to do parallel links across there, and then the same on the other side, and then the same on the other battery. But here I'm going to have one go in there, I'm going to have that one go in there, I'm going to have another one going into the middle there. So then I've got the negative tab to get these two batteries as close together as possible, and I'm going to do the same on this side. That's the theory. I've thought about this long and hard. It's the only way I can think of. It's the only way it'll fit. I've done that side. Now I know it looks like I just went and I did it all. This has taken a day to do both sides actually. Because number one, I have to keep stopping because of medical conditions, and number two, I have to keep stopping because these things get too bloody hot. Oh, I can feel that. Anyway, I've now got to go around with my scissors and bend all the tabs over on both sides, and then I can start working on the other battery. Earlier on in the video, I may have said this a couple of times, I don't know, and I might say in the future, I might be touching this battery pack like this, and I say, oh, I can't feel anything. That is me. I don't suffer with sweaty hands. If your hands sweat, your hands are wet, or whatever, you're going to feel it. Now, in certain circumstances, it can kill you. Believe me, it can kill you. As stupid as it seems, if I had two cuts on my fingers and I got blood, oh, I've worn my finger out. If I got blood coming out of my finger or something like that, out of both fingers or thumbs or something like that, and I touch that, that's going to cause you a lot of problems very, very quickly. I mean, this is 65 volts or something like that. I can't feel that. But like I say, if I've got two cuts, it'll go straight through, and straight through that bit there, and that's what you don't want to happen. So do not touch these. Don't be like me. Take precautions. Cover what you're not working on at the time. So if I'm working on that, make sure that the rest of it's covered, and you'll be fine. I know the risks, and I don't touching things like this part here, that's not going to hurt. So when I'm actually spot welding, that is possibly the only part that I'll touch. I don't touch this. If I touch it with my forearms, it hurts. But do not touch the battery terminals, because it's going to cause you, at very least, pain. At very worst, you're going to be like the squirrels, aren't you? That is the second one done. Although it's not straight, it's slightly on the skew like that, but it doesn't matter. I'm not a perfectionist. It's just pissing me off. This is running a 14 millisecond pulse with a 1000 amp battery. Things are going to get rather toasty. I mean, this wire, yeah, that's very hot. These terminals, the probes actually get too hot to bloody touch. Leave it to cool down. Don't keep going as long as you can, because it doesn't produce a very good weld, believe it or not. It might look okay, but it doesn't penetrate deep enough because it hasn't got the current. So if things get a bit warm, you know, warm to the touch, leave it 5 minutes, go away, do something interesting like woo the missus. Yeah, just stand in front of her and go woo, and you get a much better weld. All these are done now. They're all tidied up. It's so as you can run your hand over it nice and smooth, and you don't get any cuts or anything else like that, because the last thing you want is any abrasions when you put it in the casing. So that's done. It's just annoying me, that is. That is so bad. How do my glasses get dirty and I haven't used them? I've just put them down, I've cleaned them and put them down, they're dirty. I've got to get those. Oh, look at that, that looks terrible. I've got to get those up together like that. I've got to run a strip along the centre like that. Like that. And then I'm going to fold those in half. I've got to make sure that the voltages are all the same. I've got to stop touching that. I'll check the voltages, then I'll put the bridge in between, and then I can fold it over and make one big pack, and then I can link these. Yes, good idea, Tony. Do it properly. Although it's not straight. Oh, this isn't. It's so annoying, that is. Although it's like a streamline thing like that. Like that. This is part of the old battery, which was used as a protection on the outside. So I've decided that I'm going to put it on there. I'm going to fold the two halves together, and then I'm going to use that as a separation, just to be 100%. I don't know why, but here we go. So I can put that in the middle. It's not an insulator, it's just to stop things from rubbing against each other, that's all. Like that. I might need to flatten it off a bit. Those tabs that I've done on the other side are literally just for balancing, just to make sure that the two packs are 100% balanced. And obviously I've got to put the balancer in, the BMS in. So I can, in actual fact, just run some wires across there just to keep them balanced properly. That ain't straight, that's just annoying. Oh, I'm going to have to do that again. Oh, it's straighter than it was. It'll have to do. These wires here that you can see, every other one, or every third, two, whatever, these are balance wires, because on the other side, and I've got to be careful because I keep getting a shock off this now. On the other side we have balance wires, balance links going across there. These are actually the parallel links. If we imagine that these two packs, that one and that one, are totally independent of each other, but I need to keep them virtually the same voltage or at the same voltage. These links here in the middle, which are the parallel links between these two packs, all these are doing on the other side is just completing that circuit, so as they are actually in parallel, but it's literally only to balance it. Now if something bad happened and one of these cells went down, or pair of cells or bank of cells, it'd melt that and it'd protect, in theory it'd protect this side. So that's the sort of idea behind that. On this side now I can put the BMS, and I can just put the BMS and wire them up against these links. I may have to take one off the end. Ah, you bastard! I can now turn this thing upside down, put this thing in, then start wiring all the BMS up. The controller should be here next week.